So we're starting something new today because I'm tired of passing them out. Open the top drawer. Everyone but 5 at a point once you find them. They were talking when I was talking. What about me? Open the top drawer. Open the top drawer. You only need one. There you go. Okay, so I still need Seth, just in case something happens, to put table 1 or his name or something. But each table has a set color. Theirs is pink and yours is more red. Y'all's are too close, yes. That's why I need for sure, y'all. I was trying to do like Roy G. Bibb, but I didn't have an orange, that's why I used pink. I didn't have yellow, so I used white. But I had green, blue, purple. I had red, green, blue, purple. That counts. I find myself talking and other people not listening. How annoying is that? That is so annoying. Goodness gracious. Things we haven't mentioned that need to be mentioned. Next Tuesday, we're going to take a perfect cubes test. The perfect cubes were on the back of your study guide, so you might have turned it in. We're going to go over the first 0, 1, 2, and 3 today. If you at least know those, I feel like you're at least on the right path. 0 cubed is
0.
Okay, so I didn't hear that wasn't loud enough, and I mean 0 cubed is anything 0 to the whatever power is going to be 0. 1 cubed is 1, and then 2 cubed is 8, and 3 cubed is 27. So if you don't at least know 0, 1, 2, and 3, what are you doing? You got to know all 10, and you've got to know them by next Tuesday, and know they will not be in order. So if Seth memorizes 0, 1, 8, 27, 64, that's not going to help him any. He has to actually know 4 cubed is 64. It's not going to be in the correct order. Okay, as for your test yesterday, I've already graded them. I'm going to show you those at the end of class. If you didn't get to finish because you were a sophomore or because you weren't here, if I can get out my words as I need to, I will gladly let you finish that now. However, if you're super duper distracted, it ain't never going to happen. No, there's not going to be a need for test corrections because, top of this, so far, all the ones who turned it in yesterday, A's and B's.
Is that good?
Mm-hmm. Yeah, I do have a couple hundreds. But yeah, mostly A's and B's. Well, I should probably add mostly A's and B's. There were some from some other classes. I had a D. How you made a D on the matrix test, I don't know, but I did. So, I guess, I don't know. Okay, we have math workshops to go over, and then we've got new notes. Now, we are substantially behind. And part of it's because I've been out, and part of it's because I like matrices, so I spent a long time on them. So, we have to go pretty fast through quadratic functions. So we're going to skip a little bit, as is best. We'll get to that in just a moment. Can someone help me? You've had stinking long enough. My God, and the bell rang at 8:15. It's 8:27. 16 becomes what?
4.
Yes, because the square root of 16 is 4. So I get a 36. If you can tell me about the variables, I'll give you the point. Y to the 5th, and then
Z to the first. No second.
is it first or second?
Second.
First.
It's Z to the first with the square root of Z left. I'll give 1 and 2 a point. So it should be 36 y to the 5th Z square root of Z. 10 divided by 2 is 5. 3 is an odd exponent. That's why there's 1 left under the house. Your answer is 36 y to the 5th Z square root of Z. Now we are not at the end of the 9 weeks yet, but I would like to remind you that eventually there will be a math workshop test this 9 weeks. And you will have to understand how to do this on your own. 98. What times what is 98? I need one of those to be a perfect square. Again, you realize you've been wasting your own time, right? Because that was 13 minutes ago the bell rang. 13 minutes. Yes, dear? 49 and 2. Table 6 gets the point. 49 and 2. I know the square root of 49. That's 7. So I have 7 square root of 2. I just got to deal with the j. It's j to the 1 and 6 get the point. Okay, 13 doesn't have a radical, but still we're supposed to simplify. Are we trying to go for an all-time low this week as well, table 5, or we enjoyed the bad grade last week because it was awful. It's the worst math. It was the worst participation grade I've had to type in for any class period of any group. It was terrible. Yes, dear. Okay, when we multiply with the same base, what are we supposed to do with the exponents? We're just supposed to add them, so it's x to the 11th. Okay. That one I kind of gave you. If you can tell me 14, I'll give you the point. Y to the 12. Yes, Day, you can add the point. And then x to the... It's not y to the 12. That's a lie. Day, don't get that point. Yeah. 3 plus 11 plus 1 is 15. And then x to the 3rd. Kelsey, you can add the point. Sorry, Day. Yes. What?
What? Oh, no.
Okay. I was confused. Okay, number 15. 8 what?
8, 9.
Yes, okay. So I'll give Day a point and Arturo a point. Last but not least, we're dividing. When we divide, what do we do with the exponents? We do subtract, so I should end up with 8 to the what? Yes, but we refuse to leave it that way, so instead we write it as...
Don't you do the English one?
Yes, please.
1 over a squared.
Yes, dear, you can have a point. Braxton, I promise, after our next quiz or assessment, we're going to swap groups so we can get you your points back, because it is not you. Okay, so if you have a negative exponent, that's another thing we have an issue with. So you end up punishing them and sending them to the denominator, because we don't like having negative exponents. It's a problem. Okay, we're going to leave 17 and 18 for tomorrow. We're going to start our new notes packet. It was on your desk when you walked in the room. We are off matrices. We are now on quadratics. If you didn't get a graphing calculator on your way in, now is the time. Come get one. If you notice that suddenly I don't have as many calculators, you're correct. There are 2 that have wandered away from me. You're very lucky I'm still letting you use mine at all. The 2 need to return home as quickly as possible. Okay, I haven't okayed this with Miss Brister. I'm hoping she's just going to roll with it. We are going to... My plan. Today is Wednesday.
I think so.
Today's Wednesday. I see that. One can have a... Well, Patrick's not. 3 can have a point. And that black thing on my nose. Okay, so I don't know if your goal was to really get on my nerves today, but you're totally there. You're there. 100% there. Yeah, 100% there on my nerves. You're going to have a quiz on 4.1 on Monday. That's the part that I hadn't cleared with Brister, but she'll be okay with it. She'll learn the deal. Here is how that's going to happen, because other people are spending longer on 4.1 than we are. How that's going to happen is we're going to sort of somewhat cheat. So by cheating, I mean at first they want us to actually graph by hand. We're going to ignore those directions and stick to our calculators. We're going to talk about how you could do it by hand, but let's be honest, if you're actually on a standardized test, they're not going to take this calculator away from you, and on the test, I'm not going to take the calculator away from you. So while it is good to know how to do things by hand, you're always going to have this to check you. So why not start off by understanding how to use this? Yes, dear? No. It's not hard to do it by hand. You just have to remember different things. Yeah, it's tedious. It's even tedious on the calculator. Life is tedious. Okay, so what we're going to talk about is quadratic functions, which your algebra teacher taught you about. You've just forgotten.
In a quadratic.
So in a quadratic function, obviously the highest exponent is a 2. And these functions can have the term with the x squared is called the quadratic term because it has the 2. The term with x just raised to the 1 power is called the linear term. And the term where it just is a number, as always, is called a constant. So we've got a quadratic function, and then each of the 3 pieces that could potentially make up a quadratic. One's called quadratic, one's called linear, and the other's called constant. I haven't actually looked at the quiz, so I can't promise vocab's not on there, but never in my life have I heard someone refer to the middle term as a linear term. Strange. Strange. However, this one is an important one, so I'd probably put a star by it, because if I were to put vocab, this is what I would put. The graph of a quadratic is called a parabola. And yes, you are expected to know that. It's called a parabola. It kind of looks like bowl to me, parabola, which makes sense because it looks like a bowl because it could probably hold your food if you poured it in there. Okay, so to graph a quadratic, just like with a linear function, you just need some ordered pairs. You can plot your points, connect the dots. Okay, so Dontarius was asking, is it hard to do by hand? And not really, but you have to remember a lot of little details. So we're going to kind of sketch our way through number 1, and then we're going to start, I'm going to call it cheating, but it's really not cheating. We're going to start using our resources after that. So number 1, we're given this function, and they want us to find the y-intercept, the equation, the axis of symmetry, and the vertex. Well, first we've got to know what those things are. Y-intercept is where our graph crosses the y-axis. It's where our graph crosses the y-axis. And if our graph's crossing the y-axis and we were listing out an ordered pair, well, I don't know what number that is. I do know what the x-coordinate would be. What would the x-coordinate be if it's a y-intercept? It would have to be 0 because we were hitting on the y-axis. So, long story short, if we were to take, and that's what these directions up here are saying, towards the top, they go into mathy with it, but if we were to take 0, plug it in for all the x's, see what we get out for y, that's going to be our intercept. So looking at number 1, if we plugged in a 0, it would be 0 squared minus 6 times 0 plus 8. So where does our intercept happen? It only happens at 8. Again, seriously, 0 squared, you know that term's gone. 6 times 0, that term's gone. So everything's gone but the 8. So our intercept is at 0, 8. Okay, you're smart. Flip to number 2. Where would the intercept be on number 2? It would be a 6. If you said 6 and be honest, give yourself a point. Okay. Now moving on with our life. So we've got to know the intercept. So if we were to graph it, so here's my fake little graph. We want to know where it crosses the y-axis. And that's what that intercept's telling us. So for sure, I'm crossing at 0, 8. That's my intercept. Okay, but it's not just enough to find the intercept. We also want to find something called the axis of symmetry. So a parabola is kind of the way your teacher in geometry used to talk to you about things that could be reflected. A parabola matches on each side. If we cut it in half, if I took my scissors right now and cut my paper in half, each half would match. So it's reflective. So if we know, for instance, that it hits at 0, 8, well then somewhere over here it's going to hit at something else, 8. It's the same height. So we can figure out a lot. If you know one side, you know the other side. And we'll come back to that in a second. But the important thing is, if we got out our scissors, where we would use the scissors, that's called the axis of symmetry. So where you want to use your scissors. So if I were to add notes, axis of symmetry, I would add scissors. Thank you. I would add the word scissors. Axis of symmetry is if you were going to cut it in half, and it be perfect and match, where would you cut it? So where would you use your scissors? Now, in a second, we'll start doing it on our calculator. But if you wanted to calculate the axis of symmetry by hand, you can. As always in math class, there is a formula. The axis of symmetry is always negative b over 2a. Do you have to memorize that to end up acing this next test? No. Is that a useful thing to know in life? Absolutely. Absolutely. So when they say negative b over 2a, I should probably back up and let's look at our problem again. So back down at number 1. What form is number 1 in? Yes. Yes, 1 and 6. It is standard. So if our problem is in standard form, meaning it has ax squared plus bx plus c. Remember that was standard form, and you thought it wasn't useful, but it actually ends up being really useful when we're trying to figure out that axis of symmetry. If it's in this form, then negative b over 2a we can easily figure out. Our a in this case would be a 1. It's negative, but our b is a negative 6. So it ends up being positive 6 over 2, which is just 3. Meaning, if I were to get my scissors and cut my parabola over here in half, I would end up cutting it at 3. I'm going to cut it at 3. Now, we probably need some more points before we get out the scissors and start really cutting. But eventually, when I draw my U, my parabola, I could cut it at 3. Okay, so we can find the axis of symmetry. X equals negative b over 2a, so our axis of symmetry is at 3. It's not hard to calculate by hand. It just would require you to remember it. So we talked about the axis of symmetry. We talked about the y-intercept. There are some other things we need to talk about. And the next one on our notes list is the vertex. So our parabola either has a really, it looks like it's like a valley, or it looks like it's a hill. It's going to be one or the other. Our example one is a valley. And that very, very bottom point of our valley would be the vertex. Now, if it looked like a hill, the very, very top point would be our vertex. Vertex is either as low as you can go or as high as you can go. And you could probably already guess. So I kind of think, if you can tell me what's different with your notes packet this time, I will give you 2 points.
All right.
Yes, dear.
There's no homework assignment. Learning.
I didn't give you a page full of learning targets. We don't have one made for this unit for some reason. So I'm actually gonna, when we get done with the unit, I'll give you what I've been writing down. No, you don't have to write them each day. But so that stinks. So graph quadratic functions, clearly that's what we're trying to do. But the next one says find and interpret max and min values. Well, that's kind of, we're not really going to venture into that. Oh, we are in a second. But that's really easy to do if you know where the vertex is. With this first one, would this bottom point be a max or a min?
A max, min.
Is that as high as you could go or as low as you could go?
Low.
So it'd be a min. But the vertex on this one, is it high as you can go? Yes, so it'd be a max. So figuring out the max and min is going to be super easy if we know the vertex. And you're like, okay, that's great. How do we find the vertex? So if you're reading your notes up at the top, we figured out how to find the y-intercept. We figured out how to find... What's going on here? We figured out how to find the y-intercept. We figured out the equation for the axis of symmetry. And ironically, so we found out our axis of symmetry was at 3. So our vertex, which is going to be an ordered pair, the x-coordinate is that number. So we know it's 3 something. We just have to figure out the other something. So it kind of stinks. So if Gracie figured out the wrong axis of symmetry, she's going to have the wrong x value for her vertex. And it's just this snowball effect of everything going wrong. So again, it's going to be like a few tests ago where if you do it wrong, I pay attention to what happened from there. If everything else is right, I'm only going to take off for this part. Okay, so we've got that x equals 3. To figure out y, we're really going to go plug in our function. So let's look did the y-intercept. We did this for the axis of symmetry. And now we have to do a little more math to figure out our vertex. We know our vertex is 3 something. We've got to figure out that something. So seriously, with our function, we're going to plug in a 3. So everywhere you used to see an x, now we're going to have a 3. So it used to be x squared, now it's 3 squared. It used to be minus 6x, now it's minus 6 times 3, and then plus 8. So it's 9 minus 18 plus 8. So it ends up being what number? 3 times 2, 3 squared is 9, 6 times 3 is 18. I'm just combining. Yes, it ends up being -1 because 9 minus 18 is -9. -9 plus 8, it ends up being -1, yes. Yes, yes. So our vertex is at 3, -1. So seriously, all we did was go plug it in. Plug in a 3 because that's what the x value was to figure out the y value. And so our vertex is at 3, -1. So we're going to fake it and say it's over here. And like I was telling you, we're pretty smart. If this one happens, I mean, you're really smart. If our intercept happened at 0, 8, and then our axis of symmetry happened at 3, how many x values over did we go? Yes, Abby. Get a point. Okay, so we've got this parabola going. We've got the left side. We're trying to figure out, it'd be a really good parabola if we had 3 points. Right now we've got the intercept, that's 1 point. We've got the vertex, that's a 2nd point. It really would be nice to have a point over here. And that's what Abby just figured out, is that since a parabola is symmetric, and since we know it went from here to here, it went over 3, it would go over 3 more to go to there. So our point is 6, 8. So let's say that again. We figured out from the y-intercept to the vertex, we moved over 3. So if we went over 3 more to figure out this other point, 3 plus 3 is 6. That's how we got 6, 8. So seriously, if Abby finds 1 point, she can figure out the other point if she just knows where the axis of symmetry is, because it's always going to be a reflective symmetric thing. Again, all this sounds great, and we're skipping some parts. It says make a table of values that includes the vertex. Well, you and I could make a table that has, you know, x's and y's, and you and I already found out 0, 8, 3, -1, 6, 8. I'm not saying tables are bad, but again, we're going to show you in just a second how to get to that table in your calculator anyway. Might as well let it go. So I'm going to let go of part B. If you want to cross it out, you can. In my mind, if you have 3 points, you've got you a good parabola. And that's good enough for me. And then it says graph the function on graph paper. Well, while you're going to have to do that, in just a second, seriously, as long as Kenzie uses this as a reference, she can figure out the 3 main points she needs to then plot. And then, goodness gracious, it says, so we're kind of going to skip C-ish. Not really, but, I mean, we're going to use a calculator to help us do C. D says, does our function have a max or min, and find that value? What does our function have? It has a min down here at the vertex. And it is at 3, -1. So if they ask you, they're probably going to ask the min for the y number. So you might say min at -1. But as long as you understand the vertex and the min or max go hand in hand, I'm good to go. And then last but not least, your favorite words have come back to haunt you. Domain and range. Domain and range. So let me get my highlighters. Number E says domain and range. Okay, so what would the domain be for our function? What would the domain be for our function? Domain was x-axis. You're driving on the x-axis. What should we put?
036.
Is there anywhere where we can't reach out from the x-axis and touch our function? What should we put for the domain? Yes, dear? Yes. And you can have a point. The domain for almost any quadratic, there's nowhere where we can't, we're driving along the x-axis, there's nowhere that we can't reach up or down and touch our function. So no matter what for domain, I can't think of an exception to this unless it's a real-world application problem, in which case they might restrict the domain. Nowhere in graphing real life, like you're given a problem, domain you should guess negative infinity, infinity. The range is the only thing that's difficult because while we can reach out from that y-axis and touch that pink graph, at some point we can't. So when did we start and did we ever stop? What is our range? When did we start reaching out and touching our graph?
0.
Is that at 0? We reached out and touched it at 0, yes, but could we touch it any lower? Well, I get we could touch it at -2, but the lowest we could go is -1 because of this. You're right. So, and since we can touch it at -1, I'm going to put the bracket. Once we start reaching out and touching it at -1, is there ever a spot where we can't reach up from then on out because of those arrows on the end? No. So it's going to be -1 infinity. So the range is the only part you have to think about. If you could do domain and range with piecewise, because my God, I don't know why we started off with domain and range with piecewise. If you can do domain and range with piecewise, you can do domain and range with quadratics. The only one that's going to be funky is the range. And it just depends on if it's a min or a max. If it's a min, it's going to have a starting number, it goes to infinity. If it's a max, it's going to start at negative infinity, go to a stopping number. Okay, go to the next page, please.
That's just one problem?
That was just one problem. What a pain. So, here's the fun part. On your calculator. Press on. And then, you know what? We're going to press y equals.
Oh, Miss
Yes.
before we start, can you come erase my
Yes, in fact, why don't everyone, you know what, we probably all need to erase, because I don't know who did what on graphing wise, so let's clear the whole bad boy. Second mem is the plus button. Second mem is the plus button. And then I'm going to press reset, and I'm going to reset everything, all RAM, and then you press reset, yes. So again, it was second mem, and then I see a button number 7 that says reset, which sounds scary, but go for it. Then it says all RAM. You're like, all my memory? Sure, sounds good. And then press reset.
At least it works.
Where's F1?
Yes.
So it just clears out
Everything. Everything's cleared. Yes. It's all gone. Well, I mean, if you had it set on degrees, it might now be set on radians. But besides that, I can't think of anything major you'd be sad about now. Okay, so your calculator's cleaned out. You're ready to go.
Thank you.
Number 2, we want to type in, so we go to y equals. However, number 2 is really nice because it's set up for us. If your problem is not in standard form, you can't start graphing it. It has to be in standard form first. Okay, I see it's negative 5x squared. Which negative button should I press? The little one. So I'm going to hit the bottom white one, negative 5. Your X button is right here. It's got xt, theta, n on it. So I've got negative 5x. Heck, you have a squared button. It's below that inverse button you were using the other day. So I've got negative 5x squared. Now I'm going to hit the big minus 10x plus 6. So I hit the tiny button for that because it was negative 5. But when it was minus 10, I hit the big minus button. So negative 5x squared minus 10x plus 6. Does everyone have this typed in that wants it? Press graph. No, you don't. Okay, did you hit, which one are you stuck on? The x? Okay, thank you, Preston. Hunter, why am I trying to make you Preston today? Okay, press graph. Now, graph looks great and everything, but can we actually see where that vertex is, or is it off our screen? We can't. So we're going to press zoom, the button that says zoom, and then I'm going to press zoom out. I like to do zoom fit. So if you keep scrolling,
It's on 0.
it's 0 that says zoom fit. And the reason I like zoom fit is because then it literally fits your graph. Like, zoom fit means it will fit your graph on the screen. Once you press zoom fit, it fits your graph on the screen. It fits your graph on the screen. Now, normal people don't, like zoom fit, but if you want to zoom out or whatever, you've got to be able to figure out where that vertex is. So again, we're looking for, this is all the stuff we did on the last page. We want to know the vertex. We want to know the y-intercept. We want to know the axis of symmetry. And we're going to need to know, is it a min or max? And then we're going to need to know domain and range. It does look that way, and it is going to be that way because you realize, hey, I plug in a 0, it ends up being 6.
It's a max, probably.
If you don't like it, I get that this zoom is kind of ugly. So if you want to zoom differently, you can. Zoom standard is a normal 10 by 10, but then it doesn't fit on the screen. Our vertex doesn't. But it does show our intercept better on the screen. Okay, but let's talk about the other buttons besides zoom, because your calculator can do more than just graph and zoom. Your calculator can do all the math you need it to do. So let's talk about what you can do. You can press trace. And trace can show you different things like, for instance, notice trace shows you when x is 0, y is 6, meaning our intercept really is at 6. So on my paper, I'm going to write intercept 0, 6. So that I can do. Now, as for that axis of symmetry, it's going to take me a second to figure that one out. It's going to take me a second for the vertex too, but is it going to be a min or a max?
It's a max.
It's definitely a max. Now, I need to figure out where that max happened, but I know for sure it is a max. But you know what else I can list? The domain and range. I changed my zoom to zoom standard. Just mess with your zoom. Just mess with your zoom. Which part can't you see? Okay. I think I focus better now. Okay, so I know for sure my domain is negative infinity, infinity. What we've got to worry about is the range. But hold on, I agree. Miss Zoom is not working for me either. So I can zoom out, I can zoom in. I like zoom fit, but you were hating on it, so. What are we talking about? I like zoom fit. You'll learn to love me.
It didn't work.
Where did you go, zoom fit? Aren't you 0? Yeah, there you are. Okay, now the only reason zoom fit might be useful is because it does kind of help me try to figure out where that vertex is. I can make my calculator figure out that vertex for me. And if we know the vertex, the x-coordinate of the vertex is the axis of symmetry. So we pretty much got our calculator to do all the things for us. Now, trace is a great key, and trace can probably help you guess it, because you're like, oh, I think it's about here. But who wants to play that oh, I think game? Nobody. Nobody. So instead, you can always press second table to look at a table of values. But there is a slight flaw with doing that too. And you could say, oh, well, I knew it was a max, so I'm looking for the biggest number possible. It looks like, and it would work on this one, it looks like the highest number I can get is 11, because you told me it was a max. So my vertex is at negative 111. So I can figure that out using my table. So let's say that again. Seth told me it was a max. Well, actually, no, it was Ontarius. I don't know. It was someone that said 1. So they told me it was a max, so I knew to look for the largest number in the Y column. If it was a min, I'd be looking for the lowest number in the Y column. But I get that if you don't like that, there is a better way. Yes, dear? You didn't get these numbers? Your table set's going to be set on something different. Press second, then table set. Second, and then TBL set is table set. You can change. I normally do table start on 0, and then I normally tell it to count by ones. Is yours set on 0 and 1?
Yes,
Okay, and then press graph again, and then second table. Is your table still not the same as ours? It's not 0, 6?
Yeah, it is.
Okay, then you've typed in your function wrong. Go back to y equals and check it out.
0, 6, but I don't have the 11.
That's
I scroll up. Look, I scrolled up.
Okay.
I saw it was going negative, so I was scrolling up to get positives, and I scrolled till negative 111. Good question, Mia. Again, I know me and the calculator, we're BFFs the way you and your phone are BFFs, so I know way too much about him. Okay, so I can figure out that vertex and that axis of symmetry that easy, because if the vertex is at negative 111, then my max is at 11, or at that same point, so my highest point is 11. And then that axis of symmetry, it used to be x equals negative b over 2a, but Mackenzie doesn't even have to calculate it. I know it's going to be the x coordinate of my vertex, so it's at negative 1. So again, once you know the vertex, you know where the max or min happens, and you know where that axis of symmetry is. So it's just, did I actually find the vertex? Because if not, I've messed up 3 things. If so, I'm good to go. And heck, I've not only messed up 3 things, but to be honest, you're going to end up messing up 4. Because our range would be negative infinity on until 11. Because I can touch it, I can touch it, I can touch it, and at some point I can't reach up and touch it, and I bet that point is 11. I agree, the zoom on this one's terrible, but I assume that point is 11. The highest I could touch it was at 11. Now, if you're still not liking just looking at the table, because I don't like looking at the table, there's an issue with the table. What's wrong with the table? Why will we not trust the table solely? What's wrong with the table? What's wrong with the table is the fact that, what's it counting by? It's counting by ones. What if our vertex happens at a decimal? How will we know? We wouldn't. We can either go to that table set that I just took Mia to make our table count by that, or we'll talk about it. I know it's 9:01 and you've got 3 minutes to get your life together, but I'll show you a better way tomorrow. Page 7 in the notes, if you'd like to start it, you'll have time on that tomorrow too. But page be warned, there is eventually a checkpoint as well.